So in the third problem, it's an RC circuit, a resistor capacitor circuit. And so when we're trying to figure this out, we need to first off combine the capacitors. So to combine the capacitors in series, we use the 1 over C1 plus 1 over C2 is equal to 1 over C equivalent equation. So I'm going to do 1 over 4 plus 1 over 5 is equal to 1 over CEQ. I'm going to do the same thing for the 3 and the 2. When I do that, I end up with the value of 2.2. So I could redraw this circuit as the 6-volt battery, the resistor, which we didn't give a value to. I need to give a value to that. So let's say the resistor is 10 ohms. And then I would have here a capacitor that's 2.2 farads. And I have another capacitor. Capacitors have the same line length. The battery has different line lengths. We have our other capacitor, which again is 1.3, 1 1/3 plus 1 1/2. You take the inverse of that, and you end up with 1.2. So 1.2 farads. And there you go. So from there, we would combine. We would have our battery, and we would have our 10 ohm resistor, and we would have a single capacitor. Because capacitors in parallel get added together, this is just 3.4 farads, and again 10 ohms. So farads and 10 ohms. So we need to at this point do the RC stuff. This is simplified. We can't simplify this down anymore. The battery was a 6-volt battery, and so when we have a capacitor, the capacitor takes time to charge. And so we say that the voltage that the capacitor is at a particular time, voltage at T, is equal to the maximum voltage it could get to. The maximum voltage a capacitor could get to is the voltage of its battery. Sometimes we see this as IR because we do a substitution in there. IR is equal to V. It would be I max. But if we're given the V, it's the voltage of the battery. We can't have any more voltage than the source. And then we are going to multiply that by the equation 1 minus e to the negative t over RC. We call RC the timing constant. So I believe it says up here that what happens at 2 seconds. So we would say basically the voltage at 2 seconds, that's not multiplied, but it's just at 2 seconds. You put seconds there so you understand that we're just looking at that value, is equal to the maximum voltage 6 times 1 minus e to the negative raised to the negative t, which was 2, divided by RC. RC is the multiplication of the resistor and capacitor, which in this case is going to be 34. And that's our answer. So at that time, 6 times 1 minus e, and we use the button on our calculator that is located, if you have a TI-30, it's the LN button, the second LN, e to the negative 2, there's a negative there, negative 2 divided by 34, and we get 0.34 volts. So after 2 seconds, we're at 0.34 volts. The reality is the timing constant, RC, which is equal to 10 times 3.4, which equals 34 seconds, says to us that we reach 63.2%, 0.632 of Vmax after 34 seconds. So it's going to take some time to charge. In fact, the way it charges, it looks something like this. And so you can see it decays out. We reached that number at approximately the 34 second mark. I rounded here, I believe, to get the 3.4. So that's what I'm saying, approximately. So when t is 34 seconds, we have reached 63% of our maximum. And so that's how we use the timing constant to solve for the time it takes to charge a capacitor. As always, if you have any questions, please let me know.